Hi everybody, this is Dark Guardsman. We're back in the video. Now, it's unlikely I'm going to get any features or content done today. What I'm going to do instead is create a video kind of showing the work process of going through testing, as this is what I plan to work on today for Atomic Science, is actually building up test cases to test the code we currently have to ensure that it always works. Now, for those who don't really understand the concept of testing, what we're doing is we're building automated tests, as in a test that will run automatically without user interaction in order to verify that the code does run. The system we are using is JUnit. Very cool system. It's been used by a lot of companies to do a lot of cool stuff when it comes to automation testing, and it's probably the best way to actually test Java code at the moment, short of building your own system or building up other stuff. So in this case, I've already went through and I've already built up our first test case, which is test rad layer. Now this test is the Y levels in our chunk and actually verifies that the code works. Now all these tests are actually done and they've all been tested to do exactly what they're supposed to do. So we have a test that goes through and makes sure that our constructor actually runs properly. So it'll create a new radiation level. And if we pull this over here real quick, what it'll do is that the constructor will actually be created with a Y level. It'll set a Y level and it will initialize the data array. Here what we're going to do is we're going to test to make sure that Y level was set properly, that our data was not null, so as in we had data, and our data sized properly. So we are looking for an array of about 256 in size. And we ensure all that works and everything, which is nice. We also then go through and make sure that the array initializes empty, which it should. Most of these tests are kind of redundant because most of the stuff should guaranteedly work without a problem. But the reason we have it in here is it also creates a really cool concept of testing specification. So I built this class with a specification in mind. I went, okay, I want to track the Y level. I want to make sure I have a single Y level array of data that's 16 by 16. Here you can see we're testing for that. And I want to make sure it initializes as 0. So that's my specifications for how that is initialized. Here we go. We can go and test every specification to make sure that they're all there, they all work, so that if somebody comes in here later and decides, you know what, let's not make layers 16 by 16, let's do 4 by 4 layers. And what will happen is when they go to change that and actually change all the code and everything else, it'll break the tests. And this is very important because the tests rely on the comprehension that the specification works as intended. This is a really good reason why when you do a test init that you actually do this stuff, is that when somebody goes and changes the code, it triggers it and then tells you all the other tests are going to break as well. Really cool concept. You actually do another thing as well, that if this test fails, the rest of these won't even try to run. It'll just fail the entire class, but we're not going to get into that today because that's not a common thing I do. Anyways, the next thing we do, we test the index. We just test to make sure that for any value we stick in, we get the expected index value in return. Very simple method, very simple use case for testing. Index method is actually down here at the bottom. And this just does some simple checks. It just makes sure that we're within bounds, and it just does this. This, however, only actually checks this part. We actually don't end up checking this part until later. And it just ensures that we're going to get a value between 0 and 255. Everything works expectedly. If we put an index value in, we get the index value out, which is really important to test because the set and get code rely on the index to actually work as intended. Next thing we end up testing is the test data. And I call this test data, I probably really should change the name for this because we're not actually testing the data, we're testing the set and get method, hence why I've got comments up here to actually say what they are. So what we do is we really quickly just test to make sure we can set something. I use the index key in here as the data we're actually putting into there. So we go ahead and go, okay, I'm going to set into the X and Z this value which happens to be the index, and then I'm going to check to make sure that the index value also equates to our get data. And then I make sure that we reset it as well. And we do this for every position to make sure every position works in the thing, which it all does, it runs properly. Then we test the junk. There is a very important reason why you test junk data, even if you don't anticipate you're ever going to get it. One, it tests all your other cases. So if you have any other code in there that needs to be checked, and actually make sure that you're getting to that 100% test case, junk data is a good way to get to that. But the second thing is it makes sure that your code is reliable and has some redundancy into it to make sure that it will not fail. And we actually have some redundancy in the actual thing. Let me actually close this one, it's not the one I want to look at. So let's pull this one back in here so I don't get confused again. Is that we've got these checks right here. So we got some redundancy to make sure that we're not going to get bad data. If we do get bad data, it's going to guaranteedly return a -1, so that way we don't get something break in there. And this is actually useful because when I was doing the test, I discovered that if you stick a -1 in here for the Z value, that should be outside of our layer. So we shouldn't have got that value to start with. But if you do get it, it's going to result in a valid number that is going to allow that data to be set. So you could have some kind of condition something that happened somewhere else in your code that would produce a bug into this point that would have been completely valid and would have resulted in data changing inside this layer in a completely different spot than you anticipated, causing problems in the future. And you would have never found this bug out. But the cool thing is, by having the test in there for junk and by having the redundancy in there, there's no way that that bug can cause damage to the code, which is very, very important, as it prevents the mod from breaking down in the future. Like, say some other mod comes in and does something weird, or say something changes in Forge or Minecraft, or we get some kind of condition that results in that happening, there's no way that that's going to cause a problem in the future. So we got that redundancy. And the junk data actually does test this. What this really does is very simple. Is it just tries to place blocks outside the layer, because that's the only way we can test junk data at the moment. We have no other condition for junk, because as long as you're within integer minimum and maximum, that data is valid. Even if you underflow and overflow, that data is still valid, because the layer doesn't care. The layer just wants to store data, and it just does its thing. And it does all that and everything else. We also have some empty checks down here to make sure that we do the empty check. Now what the empty check actually is, this is a trick I picked up from how the chunks actually work. The chunks actually do track the number of blocks that are placed. And it's just a simple thing that goes, okay, how many blocks are used? And the chunk in Minecraft does the same exact thing, just how many blocks are used. And the reason why this is used is if this value is 0, and I know it's 0, I can then say, okay, don't save that chunk to the world, so I can just save a little bit of hard drive space. Or in memory, I can go, okay, if that layer is empty, go ahead and delete that layer and discard the data, so that way we're not wasting the 1 KB it takes to store that data that's in there. Very useful, but you do a little bit of check for that to make sure it's running. That actually checks to make sure this data is actually running right there, and make sure that that's working, and we can check that down here, and I can run all these tests. And what we can actually do is run with code coverage too. If I didn't mess something up here. Really quickly. I forgot I added dimension IDs for one of the error checks here, and I did not check to make sure I actually fixed it. I really probably should just pass the world into there, but I really don't want to have the radiation map to have an actual direct link to the world object, so that way the world can unload and I don't have to worry about it holding onto a hard reference to a bad thing. But we can see we can run this and there's no test that actually failed. Let me go actually run this again with code coverage, because that's what I wanted to actually show off. Code coverage is this concept that you basically, it's exactly what it sounds like. You're checking the amount of code that you actually covered. And this didn't actually run properly. Supposed to check how much code coverage I had in that class file. Let's see if it actually just populated the values in here. Yeah, okay, here we go. So even though this window is not working, what we can actually do is check this one. This is a really cool feature if you run code coverage while doing the JUnit and IntelliJ. It'll show you this little green line down here. If you see a green line all the way on the other side, that means you covered all of the conditions inside that method, and you don't have to worry about anything. Actually, that's not what that actually is. Completely ignore me. I'm still haven't had coffee this morning. Let's see if we can get this to run again. Took a lot of test. Rerun test. Still no code coverage. Edit. Class. All in package. Okay. And this is in package atomic. .map. And we'll just do that because that'll should in theory fix it, and then we'll rerun it. Add to active suits. Here we go. No coverage in all of its classes and scope. Sometimes you get IntelliJ break like this, because in theory, there was no test found. Edit configuration. So what we're going to do is we're going to just run a whole project. And then we're going to actually run code coverage across the entire package. Usually I create a test for this anyways at some point called test all the things, so I can run all my tests and replace active suit. What in the world? Ah, that's why. So what we want to do is we want to tell it, okay, check my code coverage for the entire package here. Oh, it's a class level check. Okay, I don't want a class level check. I want to do this. Okay. So that should work now. And then what we'll do is we'll reline that. And that's going to spam a whole bunch of data. Yeah, that's what it's going to do. So right now we only have 1% code coverage, and that was just a simple mistake, and it's a good thing I figured that out. It also shows how to figure that out on your own if you needed to. So it'll show us, okay, how much code coverage we have, and it'll go, okay, you have 1 of 55 classes covered, you're covering 5 of 602 methods, and you're only covering 22 of 187 lines that have things. And what it means by lines, it actually means conditional checks, because it doesn't actually give a crap about anything else but the conditional checks. Because that's the only thing you want to really check. It's the only thing you really can check as well. But what we could do is we go this one and you go, look, radiation layer is 100% coverage. And here's what I meant by the green lines right here is green little bars that'll show up. And it'll go, okay, you've covered this if method. And it'll go hints, okay, so you need to check 1, 2, 3, 4. And you need to make sure that you check the true and false condition each of these. So you actually end up building 8 tests just for this little section, because that's what you end up having is 8 different checks. Although I don't know why it's down here saying that you need to check the all conditions. It's probably because you're never going to run into a case where these are actually all true or all false. It does actually tell you the likelihood of each of those being hit. And you can keep going down here and you keep looking at all these, like, okay, you need 128 hits are here, and that's kind of how it runs its code, is it's running all the conditionals and everything, or it's telling you how many conditionals that you actually ran. And of course you have this one, and it says, okay, you have a conditional here, 3 hits. It'll go up here, and actually is telling me that I actually have not hit all of the conditionals here. So if you see yellow, you're only actually covering half of them. And if you see red, you didn't cover a single one. So what this actually means is that I haven't checked... Yeah, I haven't checked a condition where the previous was 0 and the value was also 0. So that's a double check there. And you also, I haven't checked to make sure that the index was actually a negative value. The thing is, the index actually can't really return a value that is greater than this. I know, actually it can. I don't know why it's saying we never actually hit it. False check, we haven't hit the false check yet. For the index is... I'm going to say we didn't hit the one for the index is greater than length, because we definitely hit the one where the index is less than. And we definitely have hit it to where it's true. We've hit a false hit 0, so we've never hit a point where the index is actually over the length, which is interesting because we didn't actually... And we didn't hit it here, so that means my tests are not 100% complete. And that's one of these tests down here is not hitting the point. But here we've got 16, -1, 16, -1. So... Ah, that's right, because the index actually can't return a value over the index length now. So it's been engineered that it won't do that anymore, so we can get rid of these checks. Generally, I don't advise actually removing checks, but if you know your code should never need this check, you can actually just trash the check. Because down here, this will always return -1 if these values are invalid. So you should either have 2 conditions. A valid value between 0 and 255 or -1. So you cannot have a value of 256 or 257, which is what that check would have checked for if it was 256 or 257 or greater. So now we know that. Now what we can do is we can rerun basically the test here. And all our tests will pass, and we still have the same amount of code coverage. And we can go all the way back down. Well, actually, we don't need to go back down. That we just go here. And what we should see is that those yellow lines should have disappeared because, well, they're not there anymore. So we got green code coverage there. So we've hit basically the code coverage required. This is the difference also between having 100% code coverage and having... I don't know what they actually call it. Having 100% completion. There is a really weird situation between this, because you can have 100% coverage and actually have not covered 100% of conditionals. So if you got all the lines covered, all the methods covered, all the stuff covered, that's cool. You have 100% coverage, but you actually haven't checked everything. Until all these yellow lines go away, you still haven't hit it. And even if you check everything, you still haven't hit a point where you're at 100% safe net, or is a good way to call it, because there's always a chance that something can happen that would break your code, that would cause it to fail, would cause something weird to happen, that this code may have not been designed to handle, which is okay. You're not going to be able to solve everything. But anyways, let's see if we can fix that last one. And we'll move on to building new test. I'll show you how to build new test the next thing we'll do. So with this one, I'm going to say we're going to do the test empty check. And what we're literally just going to do is we're just going to duplicate this one. Is we're going to have the second one. Set 0 should make it... and we may leave a note to ourselves saying it triggers a certain condition. Triggers prev equals 0 and value equals 0. And we could put a line number down here saying what line number it was. It's kind of useless to put the line number here because what happens when you reformat or change this, it's not very useful. But we got that check there, and let's see if we rerun the test. Come down here and we hit run. And you don't need to hit run with code coverage every time you do this either. It's optional. We come down here, and we still haven't hit those points yet. Now this either tells us one of two things. Either it's impossible to hit a point, or we haven't produced enough results to hit a point. So, previous equals 0 has never been false. Which is weird when you think about it. Because in this very test, we set the value to 5. And then in the next one, we set that same value to 0. So in between these two conditions, previous should have equaled 5. That's telling me that there's possibly a bug there. No, actually, it's telling me that it's been hit. It's this one that hasn't been hit right here. The combination of the two have never been false. Because in what case could these both be false? Well, the case would be if value equals... I think it's what it's trying to tell me is that if they both equal 0, then neither of these conditionals can handle it, which is expected. That's how it's supposed to run. This is an example of where you would hit a condition where you could theoretically optimize this code down, and it would tell you that you hit all the green points of it, but the amount of time I would sink into it is not worth it, especially this morning, early in the morning when I haven't had coffee. Anyway, so we're going to move on to the next thing. So the next thing is we want to make another test and keep testing our stuff. Now, the plan is if we do testing, we're not going to test everything. Like, for example, there's no point in testing radioactive dirt because what is in here? There's nothing in here. So what we would build tests for is only the logic that we anticipate a critical failure in, and stuff that if it did fail, the mod would become completely unusable. And the thing is, we would only also test things that we know would have problems to start with. Like if you're going to have, like, for example, enum AS fluids. Like, we could test this, and we could test to make sure this works, but the reality is that we know Forge functions to the most extent. So we know that if this code runs down here, we know that Forge is going to register our fluid, and if it doesn't register our fluid, it's going to give us back a fluid ID. So we know this code will run because it's run many times in so many different mods. Code that you're going to look to want to run is stuff like, for example, checking to make sure the radiation system on entities work, because that's code that doesn't exist in Forge or other mods easily, so we need to make sure we test that. We're going to want to make sure we test other things, but we don't need to test things like items. We know the items are going to register, we know they're going to work. Plus, testing... Once you start getting to testing items and blocks, it becomes harder. You have to actually start building special handling for it. I built an entire library literally called Minecraft JUnit just to deal with this stuff because of the fact it's not easy to do. And it has to do with a lot of the way Minecraft is designed, how Forge is designed, how FML is designed. There's a lot of class loading built into the system, and if you don't load the classes properly, you will actually crash trying to test your own code. And it takes a lot of experience and knowledge to fix it, and I finally got around to fixing it. And there's a few other people that have done it as well. It's just not a common thing. So anyways, what we're going to test next is we're going to move just onto the chunk thing. So we're just going to move down a layer. I'm going to stick with the radiation system. And this is a big class. It's got a lot of information into it, so we're not going to test everything in here. But what we'll go ahead and do is we'll hit up the load in the save code. Very simple thing to test. Something that you could test with almost everything. If you have an item, you have a tile, you have a block. Blocks don't really have MBT, but if you have an entity, they all have save code, and you can test the save code. You can make sure that the data you read in is the same data you saved. You can make sure that the entity restores its data properly and stuff works. You can also do the same thing for network code. So if you have network code that sends data back and forth, you can then check your network code by just simply reading and writing to make sure the read and write methods both work. Say for example, we produce a bug like down here where we accidentally left an A off that. That would mean that we would save data down here, but when it came down to here to go load, it would never load data, so we would never get that condition. We also want to check to see what would happen if this guy down here would make sure our error checks run. I doubt this code will ever run, but we're going to make sure that we at least check to make sure it produces the proper result. In this case, there's nothing we really can do to make sure this ran, because we would have to effectively catch the logger here. There is ways I do this in other mods where I actually will put a statement down here that goes like if JUnit or something, and then it makes sure that a JUnit's running, it'll go and trigger. But that's a little bit more complicated for this episode, and plus there's no real point. Theoretically, what I actually should have done right here is thrown an error, but I actually want to make this code as reliable as possible to ensure people don't think negatively of the mod if it ends up crashing or failing or whatever. Because one, if you crash during chunk loading, you're going to corrupt the chunk, which this is what this is in. More than likely, what I'm going to end up doing with this to ensure that never happens is down here when it actually loads the chunk, I'm going to put a try catch around this entire block here. So that way, if it ends up crashing while loading that chunk, it's just going to trash the data and then let the chunk load normally. So that way, I don't corrupt people's worlds. And who cares about radiation data being gone? Anyways, let's go ahead and get to the test. So when you make a new test, you just make a new test class. You want to prefix it with the word test to make sure you distinguish it. This is an example. The methodology is to always prefix, as far as I've seen. It really doesn't matter. But you want to do test, and you also want to name it, somewhat similar to what you're doing. So in this case, I'm going to do prefix. I'm going to use rad instead of radiation, so I don't have to type the full thing in. And then I'm going to do chunk. A thing to kind of help you out is you can say test cases for at length, and then you can do radiation chunk here. So that way then you can go Control B, Y, and IntelliJ, and you can jump right to the class's tests. And this helps people navigate when they're looking at your test and figuring out what is it that you tested, what are you working on, what is each of the things doing. You always want to document this, because somebody's going to have to maintain these tests in the future that is not yourself, because even though people like to think they can mod forever, that's not how this actually works. You then want to extend test case. So you get your test case up here, and then you just want to start working on your first test case. So public void test init, and that's all you have to do actually to get a method here. If you see people use @test here, that was introduced in JUnit 4, but JUnit 3 will recognize that word test in the front of things. Anything prefixed with the word test in a method in a test case will actually be recognized as a test and will be run. I, however, like to put test above here just because I think it looks nice and do that. In this case, we're going to go ahead and test things. So we got our radiation chunk equals new radiation chunk, and we're going to initialize it with dimension of 0, and we'll just put actually we're going to do like 1, 1, and 2. That way I can check things. Actually change this to 3. There's a reason why you kind of want to not use 0 as a value, and you don't want to use consistent results. The ideal would be what happens if this constructor was messed up and somebody maybe inverted the Z and the X position, and those two were inverted, and you knew that what you inputted in here, and this is actually a really good example, these are actually inverted, and those are in the wrong position. So that's an example of why you would test that and put things here. Let me actually grab that, move that. So it's usually expected that's an X and Z, but those are two inverted, and that's a good way to test with your system. But you wouldn't have been able to check it if you set them all to 0, and then your test went, okay, check to see if it's 0. Well, one, these fields will initialize to 0 to start with. If you don't put anything in them, they will be 0. Same with this guy, it'll be 0. Same with this guy, it'll be 0. So you don't want to test 0 because that's your default value. Instead, you want to put a value in there that is different. On top of that, you want to make sure your values are separated from each other. So that way, when you're checking your dimension, your X and your Z position, if you set them all to 1, how do you know which one got set? Are you sure it was the X position or the Z position that got set? What happens if dimension got put in the Z position? You wouldn't know because you put all the same data in there. Instead, what you want to do is when you're testing it, is to actually set different values, so you can then come down here and do a little assert equals check, and you can go, okay, chunk X position, and you set the X position to 3. So you want to make sure that's actually the correct data point there. And then going on to this, when you do test, you have a variety of methods to work with to test your information. The basic one is assert equals. This is going to ask, is the first input equal to the second one? And this is the expected and actual. You want to make sure you put your expected value actually in the front. And I accidentally make this mistake like all the time because I'm just not used to thinking about it. But you'll have your actual and expected positions. So the expected is what it's going to check. The actual is what it gets. And when it errors out, it'll go, okay, I expected the value of 3, but I got X. So if you flip the 2, it can lead to be a little bit confusing when you're reading your own test cases and you're not so sure. On top of this, what you can also do is put yourself a message here that'll actually print out going, X position didn't set to 3. And that'll give you a little thing there, so that way if it ended up being the wrong position, so say for example we set that to 2, and we ran this test here, it'll pop out going, X position wasn't set to 3, expected value was 3, actual value was 2. So we know that that errored out and did the wrong value. And we built up a test for this, and the thing is, a lot of people think JUnit's a bit complicated, and they don't quite understand it just because they've never used it. JUnit is incredibly simple. What you're literally doing is just asking simple questions. Is the value this? Is the value that? So on and so on. You're basically asking your code, did you do the correct thing I want to do? There is ways you can actually automate this. I've seen some people put assert statements in the middle of their methods. It's one way to do it. There's 1,000 ways to kind of do this. You could build up complicated testing code, everything else. I prefer to just use JUnit just because it's easy. Anyways, we'll go ahead and stick the other values in here rather than continuously talking about it. There are other checks as well we can run. You can run null checks, you can run not null checks, you can run true and false statements, you can run is the value actually something. So if you have like 2 values, you want to check to see if value 1 and 2 are identical to each other. That's something you can actually do rather than just running equals. I believe it is called same is what the method is called. And this will actually act the same. So if the 2 instances are not identical to each other, you actually will never get doing. A tip with that one is that very rarely you will have 2 values that are actually identical unless they literally are the same exact instance. And actually that's the definition of the variant system. Anyways, we'll check the Z position. We set the Z position to 2, so we expect it to come out as 2. And then we'll check the dimension really quickly here. And that's most of our initialized data here. Because when we actually do initialize the chunk, we can go look at this. These are the only 3 values that will be initialized. We can add another check. We can actually go, is layers null? Is this set to 0? But these are protected methods, so you can't get to them. There is a methodology when you do JUnit that you can expose everything for JUnit. But there also is a problem doing that. If you expose everything, that means you also expose it to everybody else that would access your system. And since this is a kind of an upper level thing, like down here at the radiation level, I don't care to expose these to public because nobody should be accessing the radiation levels. But when you get up to the radiation chunk, this is more accessible. This is something that's a lot closer to where people are going to be touching the code. So you sometimes want to make sure that these are protected or private, so that way people are not toying with them. Because if somebody breaks the Y star, the whole entire layer system breaks down. And if somebody messes with the layer system, it doesn't work out as it should. It's not too big of an issue, and you can easily expose this with a get method. You can easily expose this with a get method, and you can use that to test your system, which we may very well do here later. But for starters, we can just check the dimensions. So dim didn't set to 1 is what we're going to do with this one. And we expected that to be a 1, and we put this in here. And we can go ahead and run this. And there we go, all of our tests passed. We now know that the constructor will run every time and will produce the correct value, so we don't have to worry about the constructor failing on us. Now the next thing we can do is test our save load code. And when you test your save load code, it's up to you how much you really want to test. So we do test save load, and what we're going to do is you make a radiation chunk value here. And we're going to leave the data here because, to be honest, this data is meaningless, it's not saved. What we want to do is create a new MBT tag. So MBT tag save data equals new MBT tag. And then we just want to go chunk.save, save data. And then we can do down here like assert equals, and we can go, okay, save data, get tag count, I believe should be. There's supposed to be a value for this of how many tags you actually have saved. They're going to do size. Nope. Length. Nope. I actually am going to have to go stare at this. Control B is your friend when you don't know what the code's doing. Copy equals hash code. Tons of functions at the bottom here. For those who didn't know, I'm in 1.7. You can see up here. But the JUnit test holds true for any version of Minecraft because it's not Minecraft based. it's actually Java based. Although you will have to do special things for depending on your Minecraft version. There should be a function for this. I think I'm going to have to call get tag maps in that size. Now this is a little frustrating because we have this tag map here, and theoretically there should be a function somewhere in here that actually will tell us how big the tag map is, so we know how big our thing is. Ah, here we go. We can just do that. So I knew there was a method for it. It's just I'm so used to 112 code at this point. So we can go, okay, what's the size of that key set? So we should know there's so many keys in there. And if we go check our save code, we expect 1, 2, 3 keys. So we know there should be 3 keys in there, and we can put a little note here. Saved data have 3 keys. And of course, we're going to have to update this every single time we add new data to that chunk. So it's going to get a bit on the tedious end when it comes to that. So this is where it kind of is important to think about how much you want to test, because you really don't need to test everything, but it is up to you how much you want to test. And we can also do other tests like here as well. So we can do, actually I'm not going to copy that, I'm just going to type it in. So we can do assert true, and we can go save data.has key. We can be like, you should have a data key, or actually you should have a layer key is what it should be. So this should, if we go back to the chunk system here, yeah, so we have a Y-start size and layers. So we only have 3 keys, and I really should move these to public static finals. It's a really good idea when you do make MET data to kind of make static variables for it, because 1, you almost always end up accessing them in 3 different spots in your normal code, and then a 4th spot if you end up doing JUnit. So it's a good idea to kind of put these as static variables. I'm not going to worry about it right now, I'll do that later because it'll take too long to do video-wise. But we'll go back to our test here, and let's clean up the number of tabs we have open so we can navigate around a little faster. We don't care about the radiation map, we only care about this. So we want to check to make sure we have layers. So insert true, layers do exist. And we wouldn't always have layers. Theoretically, what I should be doing is I shouldn't be saving this unless that list has stuff in it, but I'm going to go ahead and save it anyways, because in theory, we should have layers, and the layers should have stuff in them, etc. if the chunk exists. But we'll add code to that. We'll add like an isEmpty check here later. They'll go through every layer and go isEmpty, 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 and everything like that. So size are the check and Y-start. So we go has Y-start, and then has size. And we can run this check as soon as we're done, and we can go, yeah, it saved all the values. And if you guys ever trip across my save load code in other mods, you'll find it actually can be pretty heavy-handed. And this is an example of where, yeah, our thing actually probably should have a null check here. This is an example of why running JUnit code is useful, because I didn't have to load Minecraft to figure this out. So Minecraft takes a while to load, and this would not have showed up until the world loaded. So I'd have gotten to the world, I would have placed a radioactive block, and then the game would have crashed. So I would have been 5 minutes waiting for the world to load, getting into the game, placing the block, finding the block, etc. like that. To just test that, when I just made a simple test, it didn't take very long, and now that guarantees that not only did I find that bug, I can ensure that bug does not replicate. Now, of course, this also means that technically, if I don't have layers, then there is no save data. So unless we initialize that, which the only way to initialize that is we're actually going to have to run a set call. So we're going to have to go chunk.setValue, and of course we're going to have to input some data, so it'll be 0, 0, yeah, we'll do 0, 0, 0, and we'll input a radiation value of 10, and we'll set some data in there. And let's create a few layers. So we'll create a layer at 50, and we'll create a layer at 232. That gives us a little bit of value, and actually do like that so it's not rounded. And that'll work, and then let's maybe put like a 5 here, we'll put a 7 here, and we'll put a 2 here. That way we get a little bit of randomized values. And this just gives us some stuff to test. We're not going to test all those values, but it guarantees that the data that is going to be saved is not going to be consistent. So that way we get a nice little broad spread over the chunk, but we don't really have to worry about too much here because we're just setting data, which will set taste data, save, and good idea to document stuff. Test save. There's actually an article that will actually tell you that you're not supposed to do this. I put comments in here because it's a waste of time. But the cool thing about this, and what they don't really point out a lot of times, is when it comes to readability, having that break in the code, because you go from bright to dark to bright to dark to bright again, it helps the eyes snap back and forth between things, and you can track where everything is really nice. So it's a good idea to document just for that reason. And then on top of that, you can go, okay, I'm saving here, I'm testing here, or I'm building data, and I'm testing down here, which is nice. So we got the test data, so theoretically when we run this, we should actually get all this value, because this should have ran. If this doesn't run, then that just means that's broken, because, yeah, index out of bounds exception, because the set code doesn't work. Exactly the reason why you want to test things. Anyways, I'm going to leave here, because this is just a good opportunity or to kind of nope out, because the video length's pretty long. But it showed off a good, decent part of like how you would go about doing this, a little bit of explanation, and I'll make probably a better video later going into much better detail about the exact things that you would do and kind of keep it in much smaller chunks. But I'll see you guys later with more videos and content.